Okay, the purpose of this video is to show you how to, an easy way to multiply polynomials with one another. More than, let's say, than a binomial times a binomial, where you'd use the process called FOIL. But when you have something that's a little bit longer, it can get pretty tedious, can't it? So there's a method called the box method that I want to show you that actually works really, really well. Okay? So here's a couple requirements. You look at your two polynomials and you have to ask yourself, are they in correct descending order? You know, does it go from x squared to x to the first to the constant? And in this case, this one does. So what I want you to do is to write out your polynomial like this. Okay, leave a little bit of space, kind of widen it out. Matter of fact, wherever you see a negative sign, or a subtraction sign, make it an addition sign. Say add the opposite, so a plus negative 2x, okay? Now with this one over here, you'll notice that it's x cubed minus x plus 4. So it's a trinomial, but if you wanted to write it with all the terms in correct descending order, you'll notice that the x squared is missing. And you'll notice that the x squared is missing. So let me just do this. Now I can't write x squared in there, else I change the polynomial. But what I can put in is 0x squared. Now we call that a dummy variable. It's called a dummy variable because it's really not adding anything to the to my polynomial, but it's holding a place. When I do correct descending order, it's going from x cubed to x squared to x to the first to the constant. Okay, and with the other second polynomial, what I want you to do is to write it vertically. Okay, so write it down the side of the box, and it really doesn't make any difference which one you put down the side. It can be this one or it can be this one, so it doesn't really make any difference. But I've got x cubed plus 0x squared plus, now remember we changed that subtraction to a plus negative, so plus negative x and then plus 4. Now what we've done here is created a box. Okay? Now we're still not quite done. What we're going to do is wherever we see a plus sign, which is one of the reasons we changed these subtractions to additions, wherever you see a plus sign, I want you to draw a line all the way across the box. There's another one. And then the same thing with the top part. Wherever there's a plus sign, draw a line all the way down. So what we've done here is we've changed this multiplication problem, this polynomial times this polynomial, into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 simple problems. Remember, I'm fond of saying that difficult problems are just a bunch of simple ones that are stacked up. Well, here's a perfect example of that. Now you go ahead and start multiplying, and this is how you do it. X cubed times 3x squared is 3x to the fifth. X cubed times a negative 2x is negative 2x to the fourth. X cubed times 6, 6x cubed. And you keep on going that way. Now you'll notice when I go 0x squared times 3x squared, I'm going to get 0 no matter what, because anything times 0 is going to be 0. So I'm just going to really add the exponent. So it's going to be 0x to the fourth. Up here it's going to be 0x cubed. Over here it's going to be 0x squared. You might be noticing something here, right? Noticing how it keeps descending. x5, x4, x3, x4, x3, x2. Let's keep going here and I'll show you how that continues to work. Negative x times 3x squared, negative 3x cubed. Negative x times a negative 2x is a positive 2x squared. Negative x times 6, negative 6x. And notice that it's still holding the pattern. X cubed, x squared, x. Matter of fact, if you go downward, same thing's happening, right? x fifth, x fourth, x third, x fourth, x third, x second. That pattern actually helps me to check and see whether my answers are going to be right. According to my pattern, this next one should be x squared. And sure enough, 4 times 3x squared is 12x squared. 4 times negative 2x is negative 8x. It works in the pattern, all right? And then finally, 4 times 6 is 24. Okay, you might be saying to yourself, okay, so great, now I've got all these things written out. Now what? Well, what I want you to do now is to draw some diagonals. So start in the upper left-hand corner, okay? And draw a diagonal through that box. Go from corner to corner. Do the same thing here. Do the same thing here. Keep on going. All the way to the end. Now look what happens. In the diagonals, they're all the same base and exponent. So here's all the x to the fifths. Here's all the x to the fourths, all the x to the thirds, all the x to the seconds, x first, constants. The reason why we do this is because now I can write everything in quickly in descending order and add it up really quickly. 3x to the fifth, that's my leading term. 0x to the fourth, negative 2x to the fourth is negative 2x to the fourth. Just add the coefficients. X cubes, got a negative 3, 0, and 6. That gives me a positive 3x cubed because they're all x cubes. Down here, 12 and 2 gives me plus 14x squared. Add these two, negative 14x plus 24. And there's your answer. Now I can kind of guarantee you that if you would have done this in the long fashion, what's called the linear fashion, like some of you probably, like you would do a FOIL, for example, this would be a very long, unorganized kind of a problem. But this box is really very interesting. There's a lot of self-checks that you can use here. Again, you'll notice that like in the first line, it goes from descending order, x to the fifth, x to the fourth, x to the third. In this direction, it does the exact same thing. On the second line, x fourth, x third, x second, same thing, right, from here. Any which direction, you always have descending order, if you did it correctly. Now, there's two requirements before you do this. You've got to make sure that your let's put down two requirements for this to work this easily. Okay? You've got to make sure that your two initial polynomials are in correct descending order. They've got to be, or else this thing won't work. The second requirement is that you've got to have all the filled in gaps. Sorry about that noise. In this case, you got to have like a 0x squared, so you can go from 3 to 2 to 1 to constant, okay? So 2 fill in gaps with dummy variables. Okay, I hope that helps. And you'll get this nice, really cool way of writing out your answer in correct descending order with kind of like a minimum of possible mistakes. All right, good luck to you.